Okay, a lot of people are dropping in. So let's start the second class today, right? So all of you hopefully can hear me clearly. So just a reminder that in case you get dropped out of the class, right, or in case if I get dropped out of the class due to some network issues, then you can just quietly log in. Okay, no issues at all. All right. So let's begin the second class. So are you all ready? And do you remember what I taught you in the last class yesterday, or have you forgotten? How many of you
Yes.
remember? Can you switch on your video, please? Let's see you. Okay, I hope all of you switch on your video. And then once I start teaching, you can go back to your mode. Okay, so for now, so all of you remember what I taught you yesterday? Yes? Shubham, Animesh, Arya, Ritam. Yes, you remember? I can't hear you. I can't.
Yes, sir.
Okay.
Yes, sir.
Fine. Yes.
Yes, sir.
Okay. So yesterday I had told you that programming is very simple, right? And it consists of just three simple things. So we had talked about statements, right? We had talked about statements or simple instructions, right? Simple instructions. Then we talked about branching, right? We talked about branching. Branching is nothing but executing simple instructions under certain conditions. All right, so branching, right? And the third thing that we talked about was doing the same thing again and again and again, which we also said,
Looping.
looping. Perfect. Okay, so
Okay.
these three are basically your ways in which you can write your program. Okay, these are the ways in which you can write your program. So any programming language that you know or you probably will write in future is based on these three important things. All right, now we will take this little further. Okay, now let me ask you a question, and the question that I want to ask you is, what is the purpose of writing a program? What is the whole purpose of writing a program? Can anyone tell me that? Anyone? So let me say, Ankit can, probably answer this. Ankit?
So the purpose of writing a program is that if we want to perform some work according to our way,
Okay.
so through program we can do it.
All right. So Ankit says that if you want to do some work, then through a program we can write, some kind of steps so that we can do that work easily. All right, that's fine. Anyone else? Anyone else would like to answer? Okay, let's see. Siddharth Singh. Can you tell me why do we write a program or what programming is all about? Anything is fine. Yes, anything is fine, Siddharth. Come on.
Sir, to program our own code.
Program our own code, but why do we write a program? Why do we write a code?
For our benefit.
Yes.
Sir, often for solving the problem.
Okay, often for solving a problem. Correct. Yes, I go with all your answers. It's absolutely correct. So you write a program to solve your problems. So what kind of problems do you actually solve? Yes, Saptak Mandal. What kind of problems do you think we solve using programs? Saptak, can you hear me? Okay, if Saptak is not able to hear me. Okay, Debalina Biswas, can you tell me what kind of problems do we solve using a program? Debalina? Okay.
Sir, the
No.
problem of communication between human and machine.
Okay, the problem of communication between human and machine. All right, good answers, good answers. I'm getting some very innovative answers, which is absolutely good. Problem of communicate. Why do we need to communicate with a machine, first of all? Why do we need to communicate with the machine such that we get problems, and then in order to solve the problems, we write code? You know, it's like going in circles, right? Let's not communicate with the machines. Yes, Siddharth, you want to say something?
Sir, to shortcut our work.
Shortcut our work. Very good answer. That means what Siddharth is saying is that to make our things or our work easier, so that I can do it faster and easier, right? That's what you're saying.
Yes, sir.
Okay, brilliant. Brilliant. All of you are right. All of you are right. Okay, I think, Anup Mohan can give the last answer and then we can move on. Anup, what kind of problems, does code solve for us? Or why do we need to program? Because all of you have joined a course where you're going to do programming, okay? So you're going to do programming for probably the rest of your years. So many years, that you're going to be there in this world, you'll be doing lots of programming. So today's class is basically why you need to program and what is the benefit of programming. Somebody told us that yes, using programming we solve problems. Absolutely right. We make our life easy. Absolutely right. You have anything to add on to it, Anup?
Sir, machines are more faster than us. Therefore, it helps us to minimize the work.
Okay.
Through coding.
Absolutely. Machines are faster than us. All right. Good. I agree to your points that human brain has got its own limitations, right? Human brains have got its own limitations. We have our own priorities. We are good at our own things. What we can do, machines can't do. What machine can do, we can't do, right? Machines can't think. And that is the precise reason that it is beneficial for us, okay? The fact that whatever instruction that we give the machine, it will execute it without thinking about it. That's what is an advantage for us. We don't tend to do this. If today I'll tell you, okay, can you jump off the window? Right? That's an instruction to you. But you will not jump from the window. I know that what you're going to do is you're going to listen to my instruction and not do it. Really, isn't it? You'll not do it. Why? Because you have the ability to analyze. You have the ability to think. But a machine does not. So if you have written a code, jump off the building, the machine will jump off the building. If you have programmed a robot to climb up the window and just jump out of it, it will. So the difference between us and a program is a program or a machine is that a machine can accept instructions. It doesn't have a logic. Whatever logic you add onto a machine, that logic will get implemented there. But every logic is based out of set of instructions. Now, let me just, go back to why we need to program, right? So if you looked at this example, which I gave you, that programming is very simple and there are only 3 different constructs to programming. One is write simple instructions, then do some branching, basically execute those instructions depending on some conditions. And the third one is where I need to execute an instructions again and again and again until my work is done. Okay, that's it. So that's what your program does. Now, if you look at all these 3, examples which I gave you, simple instructions and branching and looping, all the 3 are basically connected with your process. What is a process? What is a process? Can anyone tell me what is a process? Yes, Ritam, can you tell me what's a process?
Sir,
anything, process. We have talked about process, right? Process. Whatever comes into your mind, you can say.
sir, process is we give something instruction to the computer and the program processes it.
Okay, process is some instruction that we give it to a computer and the program processes it. Okay, so when we talk about process, is it a noun? Is it a noun or is it a verb? Noun or a verb? Anyone? English, class 10, 12. All of you have done
So
your
it's a
10.
verb.
It's a verb.
Sir,
It's a verb. It's a verb. Yes, perfect. So what is a verb? What is a verb?
Action words.
Action word, something that you do, like run, isn't it? Jump, right? Write, read, sing, dance, and process. Process is also some kind of work, isn't it? So process is nothing but a verb. When we talk about process, we are talking about following instructions according to some sequence. So if I say, if I define a process, that means if I define the sequence in which the instructions need to be executed, then I can say that, yes, I have a process in place. Do you all agree with me? For example, if I ask you, look, I have just opened a bank account. I have got an ATM card with me. This is the first time I have come from the 19th century. Suddenly I woke up one day into this century, and then, I go to a bank and they give me an ATM card, and I don't know what to do with the ATM card. So if I ask you, can you help me? Can you tell me how I should go and withdraw the money using this ATM card? So what you're going to tell me is a process, right? You will say, first take this card, go to the ATM, wait till the ATM is clear of all the people. Take this card. There will be a slot where you have to actually insert the card. After that, wait for the screen to come. It will ask you for a PIN code, right? Then you enter those PIN number, whatever it's 4-digit or 6-digit, whatever. After that, you have to wait. You will get a menu on the screen. And in that menu, you will have one menu, which is withdraw money. You click on that. After that, you have to enter the denomination, or for example, how much money you want to withdraw. After that, you submit. There's a button which will say, okay, submit. After you submit, you have to wait. The money will get released through a slot which is at the bottom of that particular ATM. Take the money, then you have to wait for the card to come out. You take the card, and that's how you basically withdraw money. So what you have actually explained here is the process of withdrawing money from an ATM using an ATM card. Now, what did we do here? We listed out all the steps in a very sequential or a ordered manner, like 1, 2, 3, 4, 5, 6, 7, 8, right? So when you list the steps, basically the instructions, each one of them was a simple instruction. And what we did was we listed them in an order. So this entire set of instructions that I listed, can I say that this is a process of withdrawing money from the bank? Sorry, process of withdrawing money from the ATM?
Yes, sir.
Yes?
Yeah.
Okay, fine. So now this entire process that I'm talking about in a program, this entire process can be defined by these three simple things that I told you yesterday. Set of instructions, branching, looping. Okay, now you can tell that particular person that, look, you can give him an example of branching condition here. So first, you check your balance. If your balance is more than 500 rupees, which is the minimum balance which the bank is supposed to have, then you can go and withdraw the money. If your minimum balance is less than 500, you can't withdraw the money. So there are conditions here. So this is an example of branching. Now there could be a scenario where the person needs 1 lakh rupees, but an ATM can dispose only 10,000 rupees per transaction. So when you have to give him the instruction for that, you will tell him that do these steps again and again and again, right? Till 1 lakh rupee is withdrawn. So what he has to do, he has to execute these steps how many times? 10 times.
10
Because absolutely, because at once he can withdraw only 10K, that is 10,000 rupees. So he has to execute all these steps 10 number of times until a condition is met. What is that condition? 1 lakh rupees. All right. So what we just discussed was example of looping. Right. So it should be absolutely clear that these are the three different things in a programming language which can define your process, which can define your logic, which can define your code. Do you all agree with me now? Are you there
Yes.
with me? Okay,
Yes,
Yes,
sir.
perfect.
yes, sir.
Now this is
Yes, sir.
this is just the half of the story. Okay, so when you write programs, when you do programming, this is just the half of the story. The second half is still left. Okay, now what is the second half of the story? The first half we discussed. We talked about the process. We talked about the process. So we write a program. We write a program to make a task easy. We write a program to define some processes. We write a program to give instructions to the computer or to the machine to do some work for us. When we talk about work, we are talking about processing. When we talk about processing, we are talking about executing instructions. When we talk about executing instructions, we talk about doing things. When we talk about doing things, we are talking about the verb. Is it clear? Okay. So we have already talked about the verb. Now there is something very important, which is a noun. Do you know what is the noun of your programming? What is the noun of your programming? The verb of your programming is process, and everybody is clear with this. But what exactly is the noun of your programming? Anyone take a guess? Try and answer. Whom I haven't asked till now. Let me see if you can answer. So, Vivek, Samal, can you say? Can you give a guess? Can you just guess something? What is the noun of programming? So let us class. Okay, Ritik says class. Okay.
No, sir.
Okay.
Sorry.
No, sir. Okay, fine. That's fine. No problem at all. Anyone else? You can also send me a chat message. Tuhina, what do you think? Do you think do you think you know the answer or any guesses? What is the noun of programming? So programming is basically, you talk about language, right? Programming language, isn't it? You talk about C, C++, Java, .NET. Naming the program. Okay, Sangbit says naming the program. All right. So, programming is a language, isn't it? Programming can be done through a programming language. So when I'm talking about verb and nouns, these are nothing but these are related to language. So this is related to the English language. So I'm just correlating this with your programming language. Okay, anyone wants to make a guess? You can also send a message on the chat box. Class or package, naming the program, class. Okay, a lot of people with object-oriented background here. All right. Yes, anyone else wants to make an educated guess or no? Then we can. Noun, the act or process of planning or writing a program. Okay, fine. All right. So let me explain. Let's say I'm giving an example. We are writing a program. Okay, we're writing a program to go to an ATM and withdraw the money. All of us know the process? All of us know the process?
Yes, sir.
Yes, sir.
Yes. So
Yes,
you can
sir.
write the program. So you can write the program easily. All right. Now, let's start writing the program. So in the program, I write my process. Okay, go to the bank, look for the ATM, right? Stand in the queue. I'm writing the process. Put the card inside the slot. Put your PIN code. Everything done. We know the process very well. The process is absolutely clear. PIN number entered. Withdraw money, 10,000 rupees. And then I press submit. And a slip comes out. What is that slip? Insufficient balance. What happened? What happened? There was insufficient balance in my account. That means I don't have money in the account. So I don't have money in the account and I have gone to the ATM to withdraw money. So now, although I know the process in and out, that means I'm absolutely perfect with the process, right? But still I did not get a money. I did not get my money out of the ATM. So was the entire process beneficial for me? Was it fruitful?
No, sir.
Not at all, right? Not at all. It was not fruitful. So process is basically only half the story. Process is only half the story. In a program, the process is only half the story. So the other half is equally important. So I can write a program, I can write all the processes, I can define everything to the point, absolutely no error, absolutely no bugs, no issues, but still that program may not be useful for me because I go to the bank to withdraw money, I go to the ATM, but I have insufficient balance. So what is the other part? Now I'm giving you a hint and a clue. Now, what is the other part in a program which is also important, because without which your program may be useless, without which the entire process, the process that we're talking about, is of no use. So what do you think is the other part now? I've given you a hint this time. Anyone? Come on, now you can answer. Condition. Okay, condition. Results. Okay, fine. Good, you're coming close. Okay, do you all have a bank account? Compiling. Okay. Do you
Yes,
all
sir.
have a bank account? Yes. All of you have a
Yes,
bank
sir.
account.
Yes, sir.
Yes, sir.
Perfect. Very good. Do you all have money in your bank account?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. Very good. Very good. Lot of money coming. Okay. Do you have a internet banking user ID password?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Please share it with me.
No.
Come on. Share it with me. Okay. I'm looking at the chat messages. Who is going to share the account number, user ID, password? I'm looking at the chat. Okay. Come on. Come on. I don't have one. Now people have started saying that I don't have a bank account. All right. No, sir. No, sir. No, sir. Nobody wants to share the account number. No, 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 no. Okay, very nice. So everybody's gone back to no. Everybody was yes, 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 yes. And now Ankit Tripathi says, I'll mail you. Ankit, share it here. No problem. You can share it here. We all are friends. Okay, account number. Aurojit has given the account number. I need the user ID password and I need the ATM pin and the CVV number on your ATM as well. Okay. So I talked about a lot of things right now. So if you heard me correctly, I talked about your account number, right? I talked about your user ID. I talked about your password. I talked about your bank balance, account balance, right? I also talked about your CVV number. Okay. And somebody is being very greedy. Aurojit is asking me to deposit money for him. Okay, very nice. I will do that, Aurojit. Okay, you just need to send me your ATM card and all the PIN numbers and all your credentials, and are you sure I'll deposit some money in your account? All right. So I discussed these few things. Now, if you look at these things here, account number, user ID, password, bank balance, CVV number, are they nouns or are they verbs?
Sir, nouns.
Nouns, sir.
Nouns.
Nouns.
Nouns. Sure, absolutely sure. Absolutely sure. All of you sure that they are nouns?
Yes, sir. Nouns.
Okay, very good.
Yes, sir.
You guys are already so good with language. You know, they're already so good with language. Okay, so we just need to do the programming part of it. The language is already, good. So the second part of the program, which I was talking about, the second side of the story, the noun of my program is nothing but what? Data. Yes. So this is the second part of my program. Now, if you remember, or if you kind of recall, when I talked about the process for going to the bank and withdrawing the money, why are we defining the entire process? Why are we defining the entire process? the entire process is being defined, right? So that we get something out which is nothing but data. What we do is, in every process, in every instruction, there is a noun which is involved. For example, insert the ATM card, done, enter the PIN number. So we talked about a PIN code. Which is a PIN code? PIN number is a noun. What is it? Is it a data? Yes, it is a data. After that, if you have multiple accounts, you select, you can have like, or for example, select the amount that you want to withdraw. So we are talking about the amount. Is amount a noun? Yes, it is a noun. Is it a data? Yes, it is a data. And the entire process of going to an ATM and withdrawing the money is because we can process some data and get some data out. What data do we want at the end of the day? We want some useful data. So the money which is coming from your bank account is useful, right? So the whole process is written just for the sake of withdrawing your money. So data is very important for a program. The entire process that we write is just for this data. Just imagine a program without any data. Yes, you can have programs without any data, but data is important for a program. So on the whole, now let's try to look into the programming part with a simpler approach. Now, when I talk about a program, what is a program? Program consists of two things. One is the process and the other one is the data. So process plus data together make a program. What is the process? Process is a verb. What is data? Data is a noun. What is a verb? Verb is all the set of instructions to do something. It's action stuff. What is data? Data is a noun. The action that you perform in the instructions is performed on the data. Okay, so when you say hit the ball, what is the action word here? Hit. What is the noun? The ball, right?
Ball.
So you just can't say hit. Hit what? You need a data. Say hit, hit, hit. I said what? Hit what? The data is missing. The program is running. Process is fine. Hit, hit, hit. But where is the data? So when you talk about a program, when you talk about programming, we have to ensure that all the data is handled properly. All my processes are written correctly. Okay. So when I talk about processes, we talk about three different things, right? We talk about simple statements or instructions. We talk about branching. We talk about looping. When I talk about data, what do we need to talk about? We need to talk about how you can store the data, how you can keep the data, how you can arrange the data, right? How you can, from the data, how you can search for a particular data. So these are the things that is connected with your data. Okay, so you will be learning about how to structure the data, how to sort the data, how to search from a data. All this you will be learning in another subject that is not covered in this semester, and that is called as data structures. You must have heard about this.
Yes, sir.
Okay, so this is a subject which will talk about how you can structure the data. But what we will learn in this now when we talk about data, no, it's a physical entity, right? It's a physical entity. Like for example, process, we can't see it. We can't see a process. When you say hit, you can't see, you can't store hit. You can only do it. It's an action stuff. But when you say a ball, the ball has got some physical properties. You can actually catch a ball. You can store a ball. You can put it inside a container, isn't it? So when we talk about data, when we talk about the data in a program, I need to find a way by which I can store the data. I can keep the data. The data has to be put inside a container. Are you able to understand me? Okay. So when we are writing when you are writing a program, important is process. We will talk about the process. Yes, process has to be written correctly, but we also need to handle the data properly. So when I talk about handling the data, we will not talk about the data structures of how to store it efficiently or how to kind of arrange it efficiently, how to extract data efficiently, or how to search from a data search a data efficiently. But for now, in a basic programming, what we need to do is we need to just have a container defined to just store that data. For example, if you ask me, sir, I'm thirsty, can you get me some water? So I will say, fine, here is the water. Can I give you the water without a container? Because water is data, right? Water is data. You asked me for data, so asking is a process. But what are you asking? You're asking for water. So if I say, here is the water, so you say where it is. You will be talking about, sir, where is a glass of water, bottle of water? So what is this glass? What is this bottle that we're talking about? It's a container. And that container, the water is, what is important is water, but that water has to be stored somewhere. We have to store it. Why do we need to store it? Because if you don't store it, how will you process it? You have to carry it around, carry it from one place to another place. So in your program, you will have to carry this data from one place to another place. So in order to carry the data from one place to another place, you will need some containers. Okay, so what we will talk about in a program is process and data. In terms of process, we'll talk about these three things. In terms of data, we will only talk about where to store the data and how to store the data, because storing of data is important. Just imagine, now I'll give you a small example before we end this class today. Suppose I invite you all. Okay, I invite you all. Let's go and have pizzas. How many of you love pizzas? How many of you love to go and eat out in Domino's? You want pizzas? Free treat. No. Okay. Origin doesn't like. Okay.
No.
No. Okay. No. Okay. Fine. No. Nobody wants pizzas. Okay. Fine. Okay.
Sir, I want pizza.
Yeah. So if you guys don't want, at least give it to me. I like it. Okay, fine. So jokes aside, so if I invite you, let's go have pizzas. I know all of you will come. Just you're saying no here, but all of you will come. Okay. So we go to Domino's. Fine, absolutely fine. And then we tell him, when we go there, we say, give me pizza. Okay, we order pizza. Okay, we order the pizza. Fine. And then along with the pizzas, because I'm giving you a free treat, all of you will.
सर अभी कोविड चल रहा है ना, तो नहीं आ सकते, आप थोड़ा भिजवा देते तो बेहतर होता।
अच्छा ठीक है, तुमको हम भिजवा देंगे घर पे। ऑलराइट, सो yeah, I was saying that, yeah, okay, fine. Suppose the pizza is delivered to you, for example. So you say, sir, along with the pizza, I also want to drink something. All right, so get me a drink, get me a Coke. I say, okay, fine, free treat, take it, right? So now the pizza delivery guy comes to your house to deliver the pizza, and what he's done is, he has got say the pizza over a cup, and the drink is put it inside that pizza box, and he's giving it to you. That means the pizza, he's carrying it over a cup, right? And the drink, the Coke, is inside your box. What are you going to tell him? What are you going to tell him? What would be your reaction? Yes, no reactions here. You are definitely going to tell him, what are you doing? Why have you brought the pizza over a cup? Don't you know where to put the pizza? The pizza has to be put inside a box. There is a specific container. There is a specific container for a pizza. You can't pour the Coke into the box and bring. What's going to happen? It's going to spill everywhere. And pizza over that small cup, that pizza can fall. Right? So there is a problem here. The problem is that guy, the delivery person, he is not putting the data, putting the pizza in the right box. He has not put the Coke in the right container. So if you look at this example, every object, now pizza and Coke are not verbs, but they are noun, right? They are noun. That means they are objects. You can store them. So when the pizza guy brought the pizza all the way from his shop to your door, you will not accept if it's open, right? You will not accept if he's carrying it in his hand and then he gives the pizza to you. You'll say like, where is the container? I said, "Khula kyun laaye ho?" So he has to carry it in a container. Why he has to carry it in a container? Because the data, pizza is data. Pizza is basically an object. It's a noun. So pizza needs to be carried from the shop to your house. So we need a container for it. So obviously the pizza delivery guy has got a container, but he has switched the container, right? So now you are giving him a lesson saying that, don't you know the pizza has to go inside the box and the Coke has to be inside the cup? You have switched it, right? Now he will say, sorry, sir. Now these are the kind of mistakes that we make when we are writing a program. So when we are writing a program and when we are dealing with our data, we need to know exactly what is a type of container which is appropriate for this data. For a pizza, it's a pizza box. For a Coke, it's a glass. Similarly, when we are talking about handling data in a program, when we talk about data that is noun, right? Every type of data, each type of data has got its own container. Are you able to get it? So you have the cup, you have a cone, for an ice cream, right? And then you have a box for a pizza. So if you notice that every object or every data which is around you, just look around your house and you'll find there is so much of data. Your mother has cooked some nice biryani or rice, but is she keeping it on the table? No, she's keeping it on a container. Is she bringing the rice inside a teacup? No, she's bringing a rice inside a nice bowl, a big bowl. Is she giving you food inside a kadai to eat? No, she's giving it in a nice plate. So every object or each different kinds of data have their own specific containers, okay, in which they need to be put. Are you getting the point? You will not eat rice from a teacup or tea from a bucket. Imagine if you want to have tea, you come to my house and I give you tea in a bucket. How is it going to be? You will say like, I'll not come to his house again, right? He doesn't even know balti mein mujhe chai diya hai peene ke liye. So big mistake. So similarly, when we are writing a program, right, we have to worry about the data. What kind of data is there in a program and how do I store it? For every data, there is a container, and we need to be very careful about the container that we're using for the data. If you put a data which is large in size into a small container, what's going to happen? Suppose I have one whole bucket of water for my bath, and I'm trying to pour it in a teacup. What is going to happen? In fact, more than half of the water is going to flow. It's going to overflow. It's going to spill, right? Similarly, if I take a cup of tea and put it inside a bucket, you're wasting the entire space of the bucket with a cup of tea. In both the cases, there is a problem. In one, what is happening is we are taking a smaller container, adding a large amount of data. So what's happening? A lot of data is going to spill. So what remains with you is only a small fraction of what you actually had. In the second case, yes, you can drink tea from a bucket. That's no problem. You can make an attempt to drink tea from a bucket. I know that you're not going to do it, but you can do it. Physically, it's possible. But imagine, it's a very inconvenient thing to do. Plus, we are wasting so much of space. Bucket is for something else. It's not for your tea, right? So these are some of the things that we need to worry about when we are talking about writing a program. So program is something which is simple to write, but we should not take it for granted because there are small, tiny things that we need to worry about. We know the programs consist of two things, process and data, and they are both equally important, right? Which one do you think is more important, the process or the data? This is a question to all of you. In a program, which one do you think has more importance? Process A or B, data?
Sir, data.
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 Data?
Yes, sir.
So without the
Yes, sir,
data, the
data.
process cannot be done.
So everyone says data. Anyone who says process, please write it on the chat box.
So without the data, process cannot be done.
Okay. Without the data, process cannot be done. Without the
So
process,
both are dependent on each other.
both are dependent on each other. So if you have to give importance to one, which one is it going to be? Or you say that, okay, both are important.
So both are equally important.
Both are equally important. Okay, fine. So I will tell you, yes, both are equally important, but it depends on, how you look at a thing. For example, both are important only in case of scenarios. Now I'll give you two scenarios, and in one scenario you will tell me, sir, data is important.
अरे मैं क्लास चल रहा है ले हमने फोटो
Yeah. Ritik, can you mute your microphone? Yes. Okay. So the point is, I'll give you two scenarios. Now you have to tell me what is important, whether data is important or the process is important. Okay. So first scenario we already talked about in ATM, right? Going to the ATM, withdrawing money. What is more important there, process or data?
Sir, both are important.
But what is more important?
Sir, data.
Data is more important, right?
Data.
Data is more important because, I asked all of you to share your data. I asked you to share your PIN code. I asked you to share your can you mute your microphone, Abhishek? Yeah. I asked you to share your PIN code. I asked you to share your user ID. I asked you to share your password. None of you did. Okay. Obviously, but I asked you to, can you tell me the process of withdrawing money from the ATM? And all of you told me the process. So I think that data is more important there because you want the data to be secure. It's important for you. Can you give me your Facebook user ID, password, all of you, quickly? Forget about bank ATM. Please share your Facebook user ID, password. How many of you are going to do that? No one. See, no one is going to share. Okay. So Facebook user ID, password is data. I don't use Facebook. Okay, fine. That's different app. Okay. I don't use Facebook. Fine. So if you talk about user ID, passwords, these are all data. Okay, so if I talk about your Facebook user ID, password, data is important. If I talk about your bank balance, your bank account, data is important because if you don't have any data inside your bank, if you don't have any money in your account, then the entire process of withdrawing goes for a toss. So data is important. Now let me tell you an application. Now say I'm making a robot. Okay, I'm making a robot. And the task of my robot, is to make it walk. So I have written a program by which I am making the robot walk. So in this case, what is important? The data is important or the process is important?
Sir, the process is more important.
Process is more important here. So now, depending upon situations, depending upon what kind of problem I'm trying to solve, sometimes the data becomes important, sometimes the process becomes important, right? So if I'm doing an application, if I'm doing, for example, a calculator, if you have a calculator, inside the calculator, there's a program which is written, right? Which is more important in a calculator, the process or the data? Obviously the process, because the process should be correct. Data is anyone can 5, 3, 4, 5, you can share the data, nobody will care. But what the calculator is performing is more important than the data. So the calculator data, nobody cares because it's all private. There is no user ID, password in a calculator. But what is important is the process in a calculator. So if you're writing a calculator application, data is not at all important. What is important is your process. If you are writing an application for withdrawing a banking application, or if you are writing a process, if you're writing a software or a program for online shopping, data is important. if you are writing an application for online payment, data is important. Okay, so depending on whether the process is important or the data is important, programming styles are different. Okay, so as Kanishka says, it depends upon the scenario. Absolutely. So if somebody asks you what is important in a program, data or process, you have to say that it depends. It depends on the scenario. It depends on the kind of problem we are trying to address in a program. So Aruchit has asked, so what's the difference between coding and programming then? Okay, in general. Well, when you talk about writing a program, right? You write a program. Program is the output of coding. Coding is the process of writing a program. Okay, coding, if you look at it, programming and coding, you can say it's the same thing. Programming, coding is just converting the what you call the logic into form of instructions. But programming is not really related to technical. So if you look at coding, you talk about code, you talk about programming language, you talk about Java, you talk about C++. So how do you write the program? So you can write the program in any programming language. So if you're using a specific programming language to write that program, you can say it is coding. So you code the program. Okay, so the output of coding is the programming. Not really. Output of coding cannot be programming, because output is something that we need. We can't say that programming is the output of coding, because programming and coding are related to each other. Programming and coding are both verbs. They are doing, they action stuff. Okay, so you can either write program, but programming involves logic. So when you're doing programming, you're thinking about the best case scenarios. You're thinking about how to make things efficient. When you're doing coding, you have already done the programming part of it. You've already done the analysis. You're just converting your analysis into a syntax in a specific programming language. But on a general note, you can say both of them are almost the same. There is not much of a difference. Okay, so what I was saying was based on the scenario. Okay, based on the scenario of whether the process is important or the data is important, the entire programming perspective changes. When I say, what do you mean by entire programming perspective, right? So now many of you in this class know C++ and Java, right? Many of you know C++ and Java. How many of you know C? How many of you know C? Those guys who know C++ must be knowing C, obviously, right? Because C++ is nothing but extension of C. So you should know the full complete C, and then you can say that yes, I know additional C++, because C++ also, there are two additional stuff that C++ offers which is not there in C. One is templates, another one is your exception handling, and also it gives support to your object-oriented programming. But we're not going to discuss all that. So Java, right? Now, based on the scenario of whether the process is important or the data is important, the entire perspective of programming changes, right? If in your application or in your problem, if you think that data is important, right? If you think that the data is important, and if data is important, then you will go with Java. If you think that process is more important for me, then I will go with C. I will not go with Java. Now, you must be wondering, like, how did I make this assumption? On what basis did I actually make this decision of going with Java or going with C? Okay, so you must have heard that Java is called as object-oriented programming language. Object-oriented. Okay, and C is called as procedure-oriented. Yeah, all of you know this difference between Java and C?
Yes, sir.
Okay, so Java is object-oriented and C is procedure-oriented. What is procedure? Does it connect to process? Does procedure connect to process? Yes. Procedure and process are very closely related. And
Yes,
object,
sir.
absolutely, because when you talk about procedure, it's a verb or a noun? It's a verb. Procedure
Sir,
is a
process.
verb. Process
Verb.
is a verb.
Verb.
Correct. Object is a noun. Is object a noun? Yes. Object
Yes,
is a noun. And data is also a noun. So see how they are connected. See how they are connected. Procedure oriented is connected to process. So in scenarios where process is more important for us, we will go with procedure oriented programming. Example of procedure oriented programming is C. Where data is important for me, process is not all that important, we will go with object oriented. That means object here means data. Okay, it means data. So the concepts of abstraction comes in, concepts of encapsulation comes in. So what are we trying to do the abstraction to? What are we doing? What is encapsulation? What is abstraction? All these are related to data. You are hiding the data, right? So when you talk about encapsulation, you are hiding the data. When you talk about abstraction, you are choosing the data. So when you talk about object oriented, we are talking about giving importance to data. Why? Because data, we are talking about applications, we are talking about problems where data is more important than process. So both are equally important for us. We can never say that Java is better than C or C is better than Java. Now, if you know Java, everything is done. It's not like that. You know, C is equally important, because do you know that most of your operating systems are written in C. Most of your system level programmings are done in C, not in Java, because Java is a high level programming language. What do you mean by high level programming language? It's very high level. You cannot actually get into the machine level programming with Java easily, because there's so many layers of abstraction there that it becomes difficult for you to actually do any programming where you need to connect to the machine. But C is not like that. C is still a lower level programming language than Java, because using C you can directly interact with the machine. You can interact with the machine much easily. So that's why both are important. So I have seen people talking about C. Don't study C. C is bekar. Just do Java. Now everything is Java. No, everything is not Java. Okay. So today what you learned is very important. What you learned is how do we choose a programming language? What is the underlying difference between procedure oriented and object oriented? I have taught you a lot of things today, and I also gave you an overview of what a program is all about. Program is not just about logic, but data is also important. And also how to figure out which is more important depends on the scenario that you're trying to replicate in your program. Is the problem that you're trying to solve. If the problem is more related to the process, then you use a procedure-oriented programming language. If the problem gives more importance to data, then you talk about object-oriented programming language. So I think today's class, this should be fine. Okay, now many of you are asking me for notes. Please remember that you are in college now. You're in university, in fact. So you should get your, you've seen in those movies, right? So students who come to the university just carry one small notebook and they come, and then in the class, that same notebook is there in all the sections. So you have to start making your own notes. So what you need to do is listen to my lectures. And when I say something which is important, which you don't know, if you know, it's fine. Many of you have learned programming and come. But I would be happy if you have learned something new today. So whatever new that you're learning, some of you who don't have any experience of programming, you please start making notes. Please write each and everything that I say, right? Some important points. So you have everything visual here. You can see my screen, what I've written on my screen. You can just quickly scribble and make your rough notes. And I will be giving you supplementary materials. So I will give you some materials to study, but they will not have everything that I am actually discussing in the class. Because when I'm taking a class, ideas come one by one. I try to bring in some examples, and these examples which I actually bring in, they are not decided from before. Okay, so these examples come, and I just think that it's relevant, and I share it with you. So you have to make your notes. Okay, Orajit has got some questions. You can ask me a question, but it's already 5 o'clock. You have another class now?
Sir.
Yeah,
yes,
okay,
sir.
Orajit, quickly ask me a question. Ask me the
Yes, a
question
small
quickly.
question, sir. Sir, actually,
Sir, when we actually joined this course, actually there I thought that some specialization such as development securities or something like that would be asked for us. Is there something that, or can we acquire from something apart from this course to get specialized at a particular topic?
Which course you're talking about? This programming fundamentals.
Computer science.
Sorry?
No. Computer science, in general computer science.
You're talking about the BCA course?
BSC course, BSC computer science course.
BSC,
if
okay.
we want to
no, you're from
if
BCA.
You want to just specialize in
see,
BSC computer science.
What do you mean by specializing? Can you tell me? Because see, undergraduate courses do not have specialization. Do you know that? Specializations are all offered in your master's level courses. If you study your BCA,